Okay, so last time we did more from chapter 10. Okay. You know, I also, if I remember correctly, I did some stuff from a worksheet also. Okay, so let me keep going then. So from chapter 10, last time, I did send the notes. We saw a bunch of new ideas, you know, like the idea of population and a sample. Remember, the whole idea in statistics, well, maybe not the whole idea, but part of it at least, is you want to analyze populations, you know, like the population of college students at SUNY Oneonta, or the population of people that are registered to vote. You know, you're basically analyzing different populations. A population is a big group under study. Well, it's a group under study of people. And I'm pretty confident it doesn't have to be just people. You know, they could be objects. I think people use statistics when they're analyzing defects, like in a machine or something. I think that came up in an example last time with like a soup can, if I remember correctly. And the idea was with a population, you know, it's not just like 10, 20, or 100 people. Usually, well, I mean, 100's a fair amount. Generally, there's going to be thousands and possibly more. In other words, you're not going to be able to talk to every person or consider every single object in the population. For whatever reason, you know, it might be time, money, you know, it might be very costly. I mean, it's one of those things where in theory you could do it, but practically you can't. That's what happens there. So that's why we have this idea of a sample. And with a sample, though, you do have to be careful in that a sample is just a sub-collection of the population, but you want it to be representative of the population. So for instance, if you're trying to find out something about everybody in New York State, you know, like, I don't know, maybe trying to figure out what everyone in New York State thinks of Donald Trump as president, or of our governor, Cuomo, you know, you're not going to focus only on people who live in Manhattan, right? Because not every New Yorker is like someone who lives in Manhattan. You're not going to also focus on everyone in Oneonta, for instance. So basically, you want your sample to be representative of your population. Now, there are different ways of getting a sample, as we saw last time. You have a simple random sample. Essentially there, every member is equally likely. That's when you have a simple random sample. Yeah, we might have seen one example of that, if I remember correctly, where everyone puts their name on a slip of paper, they put it in a bin, the bin is shuffled. Basically, everybody is equally likely. Another one is what they call stratified sampling and is cluster sampling. In both cases, you're breaking up the population into groups. With stratified sampling, you're taking different members from each group, some from all. I got it from this website, remember? Some from all. You know, you're taking maybe a random sample from each of those subgroups called strata. There's also cluster sampling where, oh, excuse me, sorry, I got it backwards. Stratified sampling, you're taking, that's fine, okay. Did I get it backwards?
I might have.
Oh, excuse me, I'm sorry, I was right. Stratified sampling, you're taking some from every of those subgroups, some from all of the subgroups. Sorry, I had to think for a minute if I got the definitions mixed up. I mean, I went over it last time anyway, so the definitions are in the notes. Cluster sampling is when you take some of the subgroups, not everybody, not every subgroup, but you're taking everyone from those chosen subgroups. So stratified, you're taking some from every subgroup. With cluster sampling, you're taking everybody from some of the subgroups. Okay. I know I hesitated for a minute. I apologize for that. Systematic sampling, there, that's when you have every 10th member. You know, you can imagine putting everyone in a list, and then you take like every 10th member or something. These two, remember, were not that good techniques, even though, I mean, I guess people do them, I don't know. With convenience, you're just basically choosing whoever's convenient for the sample. And with volunteer response, you're allowing them to volunteer. You know, I did go over this stuff last time, so I'm probably doing more than necessary now, but again, I felt better doing that. So these are just techniques that, these two techniques are not the best. The others here are good. And remember also, when we form these samples, we have to be careful. When we do these studies in general, there's bias that can occur, and bias is basically bad. For instance, sampling bias is what I mentioned already with New York State and Manhattan example. You want to make sure your sample is representative of the population. With sampling bias, that does not happen. There's also what they call voluntary response bias. Again, that's basically when you're looking only at volunteers. And why is that bad? Because generally in that case, you're not getting all the data. So there may be people that don't volunteer, but they can contribute. Usually the people that volunteer, they're the ones that have strong opinions. Like if you wanted to ask everyone in New York State what they think of Donald Trump, well, if you only consider the ones who volunteer, they're going to be the ones that have strong opinions. They may all like him or they may all hate him. I don't know, like that. Self-interest study, we saw that already. That's when the researchers have a vested interest, like that example I gave with Gatorade. Response bias, that's when the responses, remember, are not accurate. It doesn't have to be because they're lying. It could be because they forgot. Like that one example we said with the doctors, where you ask people, everyone in the sample, when was the last time you went to your doctor? Your regular doctor, that is, for a checkup. They may not be able to tell you the right answer because they may not remember when they went. They may be lying. That can happen. You can have people that lie that don't go to the doctor and they say, oh, I went last week. That's inaccurate, but you don't have to be lying. There's also a lack of anonymity. Again, that's where they fear retribution, so they don't give an honest response, as I have here. There's also non-response bias, where people don't respond for whatever reason. It's like when a telemarketer calls and you hang up the phone. So that's non-response bias. I shouldn't say a telemarketer calls. If they call and they want to get a survey from you, something like that. There's also loaded questions, as we saw. That's when the questions are worded or even put in a certain order in order to invoke a certain response from you. One example we saw last time, remember, was with the death penalty, where they might ask you, do you support the death penalty? Do you support the death penalty, even though innocent people could be killed? Something like that would be a loaded question, as opposed to just saying, do you support the death penalty? So it may be intentional, it may not be intentional, but there is that kind of bias, though. So we have that. Now, I figured that it'd be good to do some examples now. Does anyone have any questions so far about this? I figured this is the first example. I figured what I'd do is, I would read through it and then give you guys like a minute or two, or even, 3 minutes maybe, to work on it. I figured to do. We have this one that says a political scientist. This person surveys 28 of the 106 representatives. All right, this one we'll do together. In a state's Congress. There's 28 people of the current 106 representatives in the state Congress. It's hypothetical, so just bear with me. And that's through that survey, 14 of them said they support the new education bill, whereas 12 said they don't. And 2 of them said, they were undecided. Okay, that's cool. So the first question is, what is the population of the so these are the questions. What is the population of the survey? What is the size of the population? What is the size of the sample? We also ask for the sample statistic for the proportion of voters. Excuse me, not voters, the people who said they were supporting the education bill. Shouldn't say voters, let me just cross that out. All right. Okay, well, again, let's do this one together. I mean, the next one I'll let you try on your own. Actually, you know what? Yeah, let me pause the recording so I can give you guys a minute to try it out.